All right, so we are moving on in Chapter 4. All right, we are starting 4.3. All right, we're going to be talking about equivalent fractions. So this section kind of jumps around a little bit. You know, we do, just so we kind of remember where we're going. All right, this chapter started with prime factorization, and then greatest common factor. We're doing equivalent fractions. We're going to do least common multiple next. And then we start looking at exponents and scientific notation. So it kind of skips around a little bit between several things. All right, so when we talk about equivalent fractions, all right, what that means is this is two or more fractions with different numerators and denominators, but are the same overall value. All right, so it's two or more fractions with different numerators and denominators, but are the same overall value. All right, just so we can kind of solidify in our mind, 1/2 and 2/4 are equivalent fractions. All right, 1/2, this is in simplest form. What that means, if I say it's 1/2 is in simplest form, what does that mean to you? If I say it's in simplest form, where 2/4 is not in simplest form, so I'm going to write here, not in simplest form, what does that mean to you? Cameron, what does that mean to you? If I say that 1/2 is in simplest form, but 1/2 is not. Why? This is hard to explain, isn't it? Have someone help you out.
It means that it can't be broken down anymore to a smaller version of itself.
Okay.
2/4 can become 1/2.
Why?
Because you can divide the numerator and denominator by 2.
Excellent. That's exactly why. Yeah, that's exactly why. All right. So this 2/4 is not in simplest form. I'm going to kind of use this as my example. My 2/4, this has numerator and denominator have a common factor that can be divided out. So that 2/4, 2 and the 4 have a common factor that we can divide out. All right, so I typically, this is where I stray away from my requirement that you show me all your work. So I call this dividing out common factors. This is DOCF. I don't require you show me what you're dividing out. I just have you guys cross it out. All right, but if we looked at 2/4, I can divide the numerator by 2 and the denominator by 2, and I can get my 1/2. So for this section, I do want you showing me what common factor you're dividing out. But when we use it, like when I use it moving forward, as you've seen, I don't make you do that normally. You know what I mean? But for this section, I want you showing me what common factor you're dividing out. All right, so we have, let's talk about equivalent fractions. So we know that 1/2, we have 2/4. We can divide the numerator and the denominator by 2. That gives us 1/2. All right, so if I took 1/2 So 2/4 is 1/2 times 2 over 2, which gives me my 2/4. Can you guys see that's how we could get 2/4? All right, so we have 1/2 and 2/4. How else could I come up with an equivalent fraction to 1/2? So here's one equivalent fraction, here's 2. How do I come up with what would be another equivalent fraction to 1/2? And tell me how I get it. Brendan? All right, so how did you get it? So if I start with 1/2, how can I get 6/12? Excellent, which gives me my 6/12. So here are 3 equivalent fractions, and that's how I got them. All right, I'm going to do more of these so you know what the heck I'm talking about, but I wanted to talk about equivalent fractions and how you get them. Yeah. Let me show you what I'm doing, and let's see if you have questions, okay? Let me give you a problem like they're going to tell you to do. Are you guys okay with this? I just want to talk about what 1/2 is, how that's the simplest, and how we can find equivalent fractions from other fractions. All right, so let me give you an example of what I want you to do. I want you to write 2 fractions that are equivalent to 8/12. All right. Well, let's start with our 8/12. What's one way that I can come up with an equivalent fraction here? Addie? Multiply by 2. So I'm going to multiply the numerator by 2 and the denominator by 2. So here I am multiplying numerator and denominator by the same number. Now tell me something. Why does multiplying by 2/2 not change the value of that fraction? Why does multiplying by 2/2 not change the value of that fraction? Addie? For sure. Absolutely, I totally agree with you. So let's put that into words of what that 2/2 is. I totally agree with you. Why does multiplying by 2/2 not change the overall value? I love that you're using an example of cutting things up because that's totally true. Amanda? Yeah, this is a version of 1. That 2/2 is 1. And remember, when we multiply 1 times any number, we get exactly the same number back. Multiplying by 2/2 just has us dividing that same piece of whatever we're dividing into smaller pieces. All right, so you're both absolutely right. So this is going to end up being 16/24. All right, give me another equivalent fraction to this. Molly? Excuse me? What did you do? Okay, I can multiply by 10/10, which gives me 80/120. Somebody give me another one, but I don't want you using multiplication. So do one higher and one lower. So try one higher, try one lower. Someone do another one for me. Danny? Excellent. I could divide both sides by 2/2, which gives me my 4/6. All right, so on this one, I divided out a common factor. So when you are doing this in your homework, I want you to do one bigger and one smaller if possible. What is this fraction simplified? I know that didn't ask us, but what is this fraction simplified? How would I find that? Sophia? Excellent, because that's my biggest factor. That 4 is my greatest common factor of both of them. So if I divide out the greatest common factor, it's going to give me my simplest form. All right, simplest form because I DOCF'd, lots of letters here, the GCF. Now, you could do this, and you could be like, oh, I'm going to divide 8 and 12 by 2, and get to 4, 6. You're like, oh, gosh, I have another one to go. So I don't care if you actually use your GCF, all right, as long as you keep dividing out common factors, you get it in simplest form if it asks for it in simplest form. Are you guys cool with that? All right, let me give you guys another one. All right, I want you to write 2 equivalent fractions. Please do one bigger and one smaller so you get in the habit of that, so you have practice with both. 2 6/9. So I want a bigger and I want a smaller. Not everything in here is going to be hard. So it's good to have some things that are easy. All right, somebody make my bigger one for me. Ada? Excellent. 18/27. Could I multiply by any number over any number? Right? So if you didn't choose 3, you could have chosen 5. You could have chosen 10. You could have chosen -4 over -4. Like, it just has to be a version of 1. All right, so in your homework, when we check it tomorrow, it probably is going to say sample answers. Because Ada probably chose 3. What did you choose?
I did 2.
What did you choose? 2. All right, who chose something different than 2 or 3? AJ, what did you choose? 10. All right, so it's going to be a sample answer. The key is multiplying by a version of 1. 10 over 10, 3 over 3, 2 over 2. All right, somebody do my smaller one for me. Valentina? Excellent. All right, in this one, that's the only possibility, because there were no other common factors. All right, but if this was 12/18, there's a couple you could choose from, right? You could divide by 2 over 2. You could divide by 3 over 3. Are you guys cool with these? Okay. So now what I want you guys to do, I want us to talk about simplest form. All right, so we talked a little bit about what simplest form means, but let's officially talk about it. All right, simplest form means that we have a fraction where there is no common multiple between the numerator and denominator. So we talked a little bit about this already. All right, I don't care if you use the GCF. If you go into our book and you look at the example I'm going to do for you, they actually have you find the GCF and divide out the GCF. I don't care if you use the GCF. Just keep dividing out common factors until there's none left. If you know what the GCF is, because you know that's the highest common factor, then use it. All right, so we're going to DOCF as far as we can to get fraction in simplest form. All right, so here's my example. I want you to write 12/30ths in simplest form. All right, the pattern that you find, the numbers you find might be different than somebody else's when you divide out common factors, depending on what you start with, but in the end you'll have the same answer. Show me what you are dividing out when you're doing these in this section, okay? Go ahead, go do it. Cameron, do you have a question? Okay, so go do this. When you're done, just put your pencil down so I know you're finished. All right, Nico, do this for me. What did you divide out? I divided 3 over 3. What do I end up with? 4/10. Is that in simplest form? All right, what else did you do then from there? Divided by 2 over 2, and what do you end up getting? Is that in simplest form? Absolutely. Now moving forward, I just, normally as we go into like other chapters and we're doing this, I'm okay with you just crossing out the 12 and writing 4 and crossing out the 30 and writing 10, you know what I mean? Like, and crossing them out to divide out common factors, but in this, I want to see the division. All right, if you jumped right to 5 or right to 6, that's fine with me. All right? Okay. Let's talk about how we, AJ, yes? No, they're not always prime. That's a great question. They're not always prime. So what I could have 4/5, right? That's in simplest form, isn't it? So the numbers are not prime. They just don't have a common factor. Does that make sense? It's a great question. So let's talk about when we might use fractions in simplest form. Okay. I'm going to show this to you, and I want you guys to write this down. Okay, I want you guys to look at this map. Do you see the red lines on there? The red highlight on there? Yes? Okay. It says the map to the left. Let me see if I can zoom in a little bit. The map to the left shows the contiguous states, the 48 contiguous states in the U.S. What does that mean, the 48 contiguous states? What does that mean? Brendan? Yeah. So which ones are not included in that? Excellent. All right. So of the 48 contiguous states, 12 are coastal states. These states border the Pacific Ocean. Thank you, sweetheart. The Atlantic Ocean and the Gulf of Mexico. Write the fraction in simplest form of contiguous states that are coastal. So go ahead and write this. So I want you to write the fraction in simplest form of the contiguous states that are coastal. All right, so I'm just going to unfreeze this. I wrote mine as little bullet points there. All right, so somebody write my original fraction for me. Alex? 12. Where'd you get 12 from, Chap? 21? There are 21 coastal states. Well, I think I said 21, but did I say 12? Did I really say 12? Are you serious that I said 12 when I saw 21? Put the chair down. Okay, if you read it, though, it's 21. So just change your answer. Lord, help me. Seriously? Oh, good Lord. So, Alex, I'm so sorry if I said 12. So tell me what your fraction is, sweetie. 21 over 48. What common factor do 21 and 48 have? So 3. So divide out 3 over 3. And what do you end up getting? 21 divided by 3 is? 21 divided by 3? 7. 48 divided by 3 is 16. Is that simplified? Yes. So there we go. All right, you guys cool? All right, so this is using how we can write fractions and then simplifying them. Are you guys cool with that? Super easy, right? Easy day in math. Yes? Shh.
So like last year when we did fractions, I would just do specifically this problem, I would just do 21 over 48 divided by 3. Would we have to put 3 over 3?
Well, that's a good question. Let me ask you. If I have 21 over 48, listen to what I'm saying. If I say divide by 3, we want to know, is this the same thing as 21 over 48 divided by 3 over 3? What do you guys think? Are those two the same thing? Sarah?
No.
Why? That's right. 3 is not a version of 1. This is 3 over 1. That is totally different. So, yes, you have to show me that. Because I'm dividing the numerator by 3, I'm dividing my denominator by 3. This is not the same thing. That's not what you mean, and I will mark you down for that. It's a great question. Nobody should be teaching you that. Okay, so that's something I should probably talk to other teachers about. That is not the case, because this is totally different. This would be 21 over 48. What do I have to do when I'm dividing fractions? Sophia? Multiply by the reciprocal. That's actually what that means. You know what I mean? And then we would finish that. So we divide out common factors between these two, and I end up with 7 over 48. Does that help you?
Yeah.
Sweet. All right, you guys can go.